Yeah, so glycation is actually not an intended process, unlike, for example, bacterial amyloid formation. It's something that happens chemically because you have reactive species in the cell that chemically go and form bonds to proteins. And so they are not really designed to occur, but when they do occur, they tend to, if they are able to modify sort of inappropriate parts of the protein, they prevent the protein from interacting with its other interaction partners. In the case of α-synuclein in Parkinson's disease, which we've looked a lot at, introduction of a very hydrophilic sugar group, as is the case here, means that the protein cannot really aggregate to form long fibrils as it normally would. So it inhibits fibrillation, and that might seem good, but it also means that the protein is more disposed to form smaller aggregates. We haven't actually shown this directly, but there is a high probability that the protein then forms small soluble species, which we call oligomers, which can be cytotoxic. So glycation can be a bad thing from that perspective. But our work also indicated that if you have a small amount of glycated protein, that can actually very effectively inhibit the rest of the protein population from aggregating, because they can bind to the growing ends of the fibril and prevent it from growing on. But if you glycate it too much, in other words, if you make your protein too sweet, then that protein will simply not be able to recognize the fibril because it's become too different. So that is why we say that there is a sweet spot for sugar modification in order to for the modified protein to really affect the process.